In this quick video, I'll show you how to evaluate angles using cosine and the unit circle. This is part 2 of this series. What you'll need for this video, you'll need to know the trigonometric ratios, sine, cosine, and tangent, and you'll also need to have memorized the special triangles as shown here. Now you'll need to know both the radian version and the degree version, and the radian version would be like this, so this one would be pi over 6, and this one would be pi over 3. Furthermore, this would be pi over 4, and this would be pi over 4, and the 90-degree angle would be pi over 2. So let's start with question number 1. Question number 1 asks us to evaluate cosine at an angle of 5 pi over 6. What you'll need to do is find out where this lies in the unit circle, whether it's in the first, second, third, or fourth quadrant. Now, all trigonometric ratios in this quadrant are positive. Only sine is positive here, only tangent is positive here, and only cosine is positive here. I'll put an A for all. Now, take a look at the angle, 5 pi over 6. Another way to look at this is 5 over 6 times pi. If this were a 6, then we would have simply pi. And so therefore we would be right here. So we can conclude that this will be in the second quadrant because it's just a little bit less than 6. The next thing that we'll have to do is, now that you've found out that it's in this quadrant, you'll need to find out what exactly this angle represents in reference to the special triangles. So you'll need to find out the equivalent angle to 5 over 6 pi. How do we do that? Well, we know that if the angle lies in this quadrant, what you have to do is subtract pi from the angle that you know. Now, if we're in this case, you would have to take the angle you know minus pi, and if we're over here, you'd have to take 2 pi minus the angle you know. So in our case, we know it's here. What I'll do is take pi and subtract it from 5 over 6 pi. The way we do this really quickly is find a common denominator. So we know that the denominator for this term is 1. I'm going to multiply this by 6 and this by 6, and I end up with 6 pi over 6 minus 5 pi over 6. Notice the denominators are the same, so I can subtract the numerators, and I end up with pi over 6. What this tells me is that the angle that also represents 5 pi over 6 is pi over 6. Once you've figured this out, you're going to refer back to your special triangles. And remember, the special triangles look like this, where if you have pi over 6, pi over 3, and pi over 2, the angle across pi over 6 is 1, and the angle across pi over 3 is the square root of 3. The hypotenuse is a 2. How do I know this? I've memorized the special triangle, and so should you. Cosine is adjacent over hypotenuse. That's the ratio that represents cosine. Adjacent is, and I'm going to write this down, cosine pi over 6. Adjacent is the square root of 3, and the hypotenuse is 2. Now remember what I said earlier. Cosine is only positive in this quadrant, and only sine is positive here. So therefore, our final answer needs to be negative. So our final answer is the square root of 3 over 2. Our next example is a little bit more difficult because this time the angle is greater than 2 pi. Now remember, 1 full spin is 2 pi. Take a look at this angle, 59 pi over 4, and compare this to 2 pi. Which one is bigger? Obviously this one. But how much bigger is it from 2 pi? The way we find out is we take 59 pi over 4 and we divide it by 2 pi. If we divide this by 2 pi, we'll take the reciprocal of this term, 1 over 2 pi, change that to multiply, and multiply all of this out, and we end up with 59 pi times 1, that's 59 pi, and 4 times 2 is 8 pi. The pi's cancel out, and we end up with 7 and a little bit. So what this means is that this will be 7 spins. 7 and a little bit. But how do we find out where it will be in its 7th spin? To do that, what we'll do is take 59 pi over 4, and you're going to subtract it from 14 pi. And the way I found out 14 pi is because I took 7, and I know 1 spin is 2 pi, so I multiplied 7 by 2 pi, and I got 14. So I'm going to subtract this number by 14, and we end up with 3 pi over 4. But where is 3 pi over 4? Is it in the first, second, third, or fourth quadrant? Well, the way we find out is, think of it this way. First, let's break this down into 3 over 4 pi, which means 3/4 of a pi. Now this is 0 of a pi, this is 1/4 of a pi, this is half of a pi, and this is 3/4 of a pi. It has to lie in the second quadrant. That being said, we still don't know what 3 over 4 pi represents. I mean, we can look at this, we know that it represents this much. But to be precise, what I'm going to do, as I did before, is I'll take pi, since it's in the second quadrant, and subtract it from 3 pi over 4, and I end up with pi over 4. Let's draw out the special triangle. This is the pi over 2 angle, in other words, our 90-degree angle. This is pi over 4, this is pi over 4. In other words, 45, 45, and 90. And across from this is 1, and across from this is 1, and across from the 90-degree or the pi over 2 angle is the square root of 2. So what we'll do now is find out what cosine of pi over 4 is equal to. Cosine is adjacent over hypotenuse. Adjacent is 1 over the hypotenuse, which is the square root of 2. Now remember, cosine cannot be positive here. Only sine can be positive there. So our final answer has to be -1 over the square root of 2. And that's it. Those are 2 examples on how to use the unit circle, special triangles, to find out equivalent angles so that we can evaluate them using cosine quickly. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.